Assalamualaikum, dear students.
Walaikum Assalam, sir.
Walaikum Assalam, sir.
I hope that all of you will be fine and you have enjoyed your quiz number 2. And I'm seeing here that I have received almost one. Taha bin Naeem. Okay, I have received some 180 responses, more than 180 responses in the quiz. However, in class, now I have 127 attendees only. So what is the reason why? It means that you people are not bothering for your attendance. You are not paying attention towards the lectures, and in this course your attendance will be counted. It will be included, and there are some marks for the attendance as well. So be attentive towards your attendance and take it seriously. Okay, the next thing is that who is Mr. Rahil Abid?
Sir, 18 से हैं सर, 18 सेशन से राहिल
18 सेशन से हैं और इन्होंने रजिस्टर किया है।
सर ये इन्होंने रेगुलेशन करवाई है, एकेडमिक वालों ने कहा था इन्हें ऐड करने का, मैंने आपको मैसेज भी किया था इनसे रिलेटेड।
अच्छा, चले इन्हें हम ऐड करते हैं और उसके बाद हम अपना लेक्चर जो है वो शुरू करते हैं, ठीक है?
शुक्रिया सर।
सो वेट अ मोमेंट। इनका रजिस्ट्रेशन नंबर क्या है? 18-EE
115 सर।
115। चलें जी, इनको मैंने ऐड कर दिया, ठीक है?
थैंक यू सर।
ओके जी, अब मुझे ये बताएं कि आप मुझे क्लियरली सुन सकते हैं और लेक्चर स्लाइड्स आपको विजिबल हैं, ऐसा ही है?
यस सर।
ओके जी, और कोशिश करें कि जी बीच में डिस्टरबेंस ना करें, फिर मुझे बार बार टीम्स पे जाके आप लोगों को म्यूट करवाना पड़ता है, ठीक है? सो ट्राई योर बेस्ट नॉट टू मेक disturbance, not to create disturbance during the lecture. Okay. In lecture number 8, actually the slides for lecture number 8, we already have discussed that what is the cost of search, what is search in binary trees, and then in that we have a comparison of the linked list or the arrays with the binary search trees. And in that analysis of the cost of search, we have an algorithm, or we have a numerical problem that if we have 1 million nodes of a linked list and we want to search a particular node from those 1 million nodes, it might take time up to 1 million. We have to visit, we have to traverse 1 million nodes in the case of linked lists. It is the possibility because that is a linear data structure. However, in the case of trees, and specifically for the binary search tree, 1 million nodes will take up to 20 levels. The tree of the 1 million nodes will only take 20 levels, and we have to just search the 20 levels for searching any element within the 1 million nodes of a binary search tree. So the comparison is very much clear that binary search tree makes the search algorithm, makes the search process very fast, very quick. And most of today's searching algorithms are based on binary search trees. Not this binary search tree, but some advanced versions of the binary search tree. So you can see you have Google, you have YouTube, and you have other applications. You are using them day by day. So you can observe that you search for any of the video and you search for any of the material on the Google, it takes your text, your searching query, the text, the keywords. On the basis of those keywords, it makes a key and it compares that key with the searching with the available data and how quickly it searches that data for you and the associated links for you. Then we talked about the binary search tree. So binary search tree is a tree in which we have the root and then left subtree and right subtree, and we will manage the smallest numbers in the left subtree and the numbers those are greater than, larger than from the root, we will adjust them in the right subtree. So such kind of a tree is called binary search tree. And then we talked about the traversing of a binary tree, and we taken 3 nodes as an example, and we have already discussed that there are 6 possibilities, 6 permutations which we can adapt for, or which we can follow for the traversing of a binary tree having 3 nodes. However, on the basis of these 6 permutations, we have defined 3 traversing common ways. Those are pre-order, in-order, and post-order. And then we discussed their relevant code and relevant examples. How we can traverse a binary tree by using pre-order traversing, in-order traversing, and post-order traversing. And by seeing the examples of traversing, we have found that in-order traversing is the traversing which perform not only the traversing function, however, it makes the data in a specific arrangement, in a specific order. That's why if we want to sort the data as well, then we can use the in-order traversing method. And these were the codes, and this was the example. Then we talked about the stack layout during a function call and recursive call of the function. Then we have seen an example in which we have performed the pre-order, in-order, and post-order traversing using recursion or recursive function. And then after that, we discussed non-recursive traversing, and then we have a comparison for that as well. And now in today's lecture, right after that, we have seen the level order traversing, which is the next type of the traversing. And after that level order traversing, we have seen plenty of examples for the binary search tree. All of those were containing the data type integers. Most of them were numbers. So there must be a sense developed that binary search tree can only perform its operations on the numbers. However, this is not the situation, this is not the case, because binary search tree can handle other data types as well, like your character data type, string data type, floating data type, any kind of data type can be handled by the binary search tree. So up till now, we have used the integer-based examples for the understanding of binary search trees because those are easy to understand. So now we will be having an example of other data types as well. The examples of binary trees so far have been storing integer data in the tree node. This is surely not a requirement. Any type of data can be stored in a tree node. Here, for example, is the C++ code to build a tree with character strings. Now, here we will be using a binary tree, and that binary tree will be containing the data character strings, not the integers. So it means that binary tree or trees can hold other data types as well. They can handle other data types as well. Now, in this example, you can see that, and this is the code. You have a method, you have a function, and that function name is void word tree. Void is its return type, and word tree means its name is word tree. It's a tree of words. And here you are using the in the very first line, you are using the same template class of the tree node factory. So you are calling that, and you are saying that tree node class create a tree node for me must hold a character data type. And before it was holding the integer data type. And the first node will become the root node. So it's a root pointer is equal to new tree node, and that new tree node will be holding the characters. Right, you have a static array, and it is also of character type, and the name of the array is word. And you have statically assign the values, and these values are babble, fable, jacket, backup, eagle, daily, gain, bandit, abandon, abash, accuse, economy, adhere, advise, so and up to chain. So you have declared an array, and you have initialized that array as well with the following words. So these can be any words. So why you need these character words or character strings to be utilized with the binary search trees? So if you take the example of, if you remember the example of directory, telephone directory, and if you remember the example of voter list, so there must be data involved which is just like character data type or string data type. So you have to handle those data types as well. So if you take the example of a telephone directory, the old PTCL directory, which is nowadays because of the mobile technologies and mobile telephones, which is not that much in use nowadays. However, we can take that example, or you can take the example of a dictionary where you have plenty of words from A to Z, and the words starting from A, the words starting from B, and then C, and then D, and then onwards up to Z. So how you can take those words, and then you can search a certain word in the English dictionary. Let's suppose you have the English dictionary, Oxford English Dictionary in the soft form. You have the application for that, and you have installed that application in your mobile phone or in your laptop. So how that is working, that is just an application software, and how that is working, how that is searching words for you. So there is a criteria involved for the searching. So same in that way, you can make a binary search tree of the words, and you can sort them in a specific order as well, in alphabetical order as well. So how you can do that, we can see all this in the following example of binary search tree. And this binary search tree will handle strings, character strings, and these are the words which we have supplied to this character word static array. And at the end, if you see the last character, we have put that as null. So before, if you remember the DST which we made from the numbers, from integer values, at the end we put a -1 value, if you remember. Now in this case we have a null value. Why we are doing this? Why we are adding a null value at the end of this? Who will give me the answer? G. Why I am adding null, and before in the integer examples we have added -1 just like that. So here we have no -1. We are, instead of that -1, we are adding a null character or a null string here. Why we are doing this? G. So if you remember, we will be using a for loop, and we have already used a for loop in our previous example of the integer cases when we were making a binary search tree with the help of integers. So at the end I put a -1 value, because if I want to terminate the loop, then I have to put such certain conditions over there. So here in this case, I'm putting a null character here, and this will be useful in the upcoming lines of codes where I have to terminate the while loop, and this null character will help in the termination of the while loop. Then root arrow set info word of 0. Word of 0, word is the array name, and word of 0 means at index 0. Whatever the character string you have, that is Babel, that will be assigned onto the root node. Then you have a for loop for I equals to 1, word of I plus plus. So binary search tree with integers, to build a binary search tree with the help of integer values, it was easy, because you have to put the smallest numbers of then the root in the left subtree, and the greatest or largest numbers than the root, you have to put them in the right subtree. So how you will do this with the character strings? Because for the numbers it is easy, which one is greater, which one is lesser or smaller. So for the character strings, how you will compare them? G. How we can compare them, and how we can say that this character string is smaller, it should be in the left subtree, or it is greater, it should be in the right subtree? How we can decide that?
Sir, every character has their ASCII code, so we can compare with them.
Yes, every character, every word, every string is composed of characters, and every character string having its representative ASCII code. And with the help of that ASCII code, we will compare them, and we will decide that which character string is smaller and which character string is greater, and we will place them accordingly in the left subtree and in the right subtree. Okay? So here we have a for loop to iterate through through this array of words for I equals to 1, because word of 0 we have already set that babble on the root node. So next will be word of one, that is fable or fable. So for I loop, the loop of the array will start from 1, index 1, and it will go onwards, and it will increment one by one word of I, and we will insert the newly words with respect to the root. Insert root comma word of I. Here we have utilized the same insert routine or the insert function, insert root comma word of I. Root is the um, very first node of the binary search tree, because we are going to make a binary search tree from these character strings. Okay? So insert root comma word of I in order of root, C out and L. So what we are doing, we are inserting the words one by one into the binary search tree, and they will be inserted as per their proper place according to their lexical order. Lexographical order. Lexographical order means their representative ASCII values will determine their position in the binary search tree. Then you have the in order traversal, which you are calling with respect to the root, and this will be recursively called, and it will sort out all the elements of the tree at the end. Now here is the insert routine, same like that we have used for the integer numbers. So void insert tree node template. Now it will be based off characters, and there will be a root, and there will be an info pointer which will insert the new word into the binary search tree. So what will be the criteria? Tree node char static node equals to new tree node char of info. So a new node will always be created, and the information in the info will be assigned to that newly node. And then we have the two pointers. If you remember P and Q, which we were using for the insert routine before for the integer values. So same, those two pointers will be used to move in the tree node char static P static Q. Initially P and Q, the two pointers, they are pointing towards the root. Now sorry. So before we were also using while loop for the integers. However, for the integers they were simple and we can compare them. And here we have character strings, so we cannot compare them directly. We have to use two methods. Either we have to compare them by using a built-in function that is available in the string class. So string compare, strcmp is the string compare function. If the two strings are equal, it will return 0. If the two strings are not equal, if one of the string is greater than the other one, then it will return 1. And if the two strings are smaller, if one of the string is smaller than the other one, then it will return -1 or 2, whatever the value has been set or defined by the string compare function, which is a built-in function. You have to just utilize it. Now this is one of the method. The other method is that you can overload the operators which you can utilize with the integer numbers. You can overload those comparison based operators for the character data type as well. So here we are not using the overloading function. We are just using a string compare function, which is a built-in function, and that is available in the string class. While strcmp info is the new word which is going to be stored in the binary search tree. So info, p arrow get info is the existing node, what information it has. So both of them will be compared, and on the basis of that, you will make the binary tree. You will put that new word in left subtree or in right subtree. Have not equal to 0 and q not equal to null. ठीक है, आपका while लूप तब तक चलता रहेगा जब तक स्ट्रिंग कंपैरिजन को दो नए वर्ड्स मिलते जाएंगे और वो उनको बारी बारी कंपेयर करेगा और उन्हें लेफ्ट या राइट सब ट्री में प्लेस करता जाएगा। ठीक है, और ये कब तक चलेगा? जब तक कि क्यू नल नहीं हो जाता। ठीक है, initially p equals to q, because p and q both of them will be pointing on the root node, and then they will move forward. If string compare strcmp info comma p arrow get info less than 0. So less than means 0 means the value is smaller than the root node, so it will be placed in the left subtree. So q will be moving towards q equals to p arrow get left. Else means you have to move towards the right subtree. Q will be equal to p arrow get right. So on the basis of this, the while loop will complete its task. Okay. So now, how the while loop will terminate? There are two possibilities. The while loop will terminate either we have finished all the words, all the information that is available in that array of the words, if they already have been finished, or the q pointer will become null. In these two cases, the while loop will be terminated, and right after the while loop we have an if statement. If strcmp info comma p arrow get info equals to 0. So this is the case when a while loop will be terminated, when you have the same value of when the two words, they have the same value or they are equal. So it means when they will be having the same value, when they will be equal, the same words. So if string cmp info comma p arrow get info is becomes equal to 0, then it means that cout attempt to insert duplicate, and you will not insert that word, you will just print out that word static info endl, and the newly created node will be deleted and it will not be assigned in the binary search tree. This is one case when the two strings or the two words are the same words, it means they are duplicate. The next case for the while termination of the while loop is that q becomes null, and when q will become null, when you have finished all the words available in your character array. So in that case, else if strcmp info comma p arrow get info, in that case it means that either info and p arrow get info, they are less than 0. So less than 0 means they will be stored in the left subtree. P arrow set left of node, else it will be stored in the right subtree. P arrow set right of node. So now this was the code, and all you have used this code for the building, for the creation of a binary search tree with strings, and these strings will be created. And insert method, we have discussed this in detail, how this insert method will work, how it will compare the character strings, and on the basis of that it will decide it should have to move towards the left subtree, towards the right subtree, or maybe there are some duplicates, so it will alert you for the duplicates as well. So right after that, you can see this output. And from the output, you can observe that you have all the character strings, character words in an alphabetical order. Abandon, abash, accuse, adhere, advise, babble, backup, and up to jacket, the last word. So why they are in the sorted order? Because you have applied a right after the insert function, you have applied the in order traversing as well, and in order traversing makes the sorting as well. Okay, so you have all those words in sorted order. So if you have a voter list, you want to sort out that. If you have a dictionary, you want to sort out the words of that dictionary, or if you have PTCL directory or a telephone directory, you can sort out that as well by using this binary search tree mechanism. Clear? If you have any question, you can ask. G. Any questions? Okay, no questions. Let's move forward. So now you have this output, and if you notice that the words are sorted in increasing order when we traverse the tree in order manner. This should not come as a surprise if you consider how we built the BST. For a given node, values less than the info in the node were all in the left subtree, and values greater or equal were in the right subtree. In order prints the left subtree. So what was in order traversing? Left, node, and right. So in order prints the left subtree, then the node, finally the right subtree. Building a BST and doing an in-order traversal leads to a sorting algorithm. So we have plenty of this. This is very basic sorting technique of the binary search tree for applying an in-order traversing on that. However, sorting is a complete chapter in your course, and we will discuss plenty of sorting techniques in that, and we will compare them as well for their efficiency, for their effectiveness. And here it was just one example with the binary search tree and with the in order traversal that you are using sorting. So what you have done, you have created a binary search tree of words, and then you have sorted that binary search tree into an in order traversal, and you have a sorted output. So if you have such type of a data and you are being assigned a task to sort out that, then you can easily make a binary search tree for that data, and you can call in order traversing on that data, and it will be sorted for you. Notice that the words are sorted in increasing order when we traverse the tree in order manner. ठीक है जी, ये हम डिस्कस कर चुके हैं. नाउ ये तो था अब तक कि बाइनरी ट्री पे आप एलिमेंट्स को कैसे इंसर्ट करते हैं, कैसे सॉर्ट करते हैं, ठीक है, ट्रेवर्सिंग कैसे करते हैं. अब हम पढ़ेंगे कि बाइनरी ट्री में कोई एलिमेंट या नोड डिलीट कैसे किया जाता है. ठीक है, डिलीट ऑपरेशन के बारे में बात करेंगे, इंसर्ट ऑपरेशन की हमने बात कर ली, ठीक है, ट्रेवर्सिंग के ऑपरेशंस की हमने बात कर ली. Now for the delete operation is the most complicated operation in all data structures. As is common with many data structures, the hardest operation is deletion. देखिए हमने लिंक लिस्ट के केस में भी पढ़ा कि डिलीट कैसे करना है, हमने अरेज के केस में भी पढ़ा, ठीक है, और जो भी उसके कॉन्सिक्वेंसेस थे उनको भी डिस्कस किया। इसी तरह क्यूज पे कोई एलिमेंट कैसे डिलीट किया जाता है, स्टैक्स में से कैसे डिलीट किया जाता है। नाउ वी विल बी डिस्कसिंग कि हाउ वी कैन डिलीट और रिमूव a binary a node from the binary search tree. So why you need to delete a node? Because you may have a voter list. अगर एक वोटर ने अपना वोट कास्ट कर लिया है तो जो एक वोटर लिस्ट है आपके पास, ठीक है, तो आपने एक अलग से एक लिस्ट मेंटेन करनी है और आपने कहना है कि जी ये लोग हैं जिन्होंने वोट कास्ट कर ली है ऑलरेडी, ताकि ये दोबारा वोट कास्ट ना कर सकें, ठीक है। So you have to delete that node from the binary search tree and you have to place it in a separate list. Same is the case when you have you have a telephone directory and a person living in Texla city having his number here in the telephone directory. Now that person has moved towards Lahore. He has shifted his house, his permanent residence from Texla to Lahore. So his number should be changed. So you have to delete that person from the telephone directory of people living in Texla. So you need deletion in that case. So in binary search tree, how you can delete nodes? Let's see, let's examine this. Once we have found that the node to be deleted, we need to consider several possibilities. First of all, it will be told to us which node we have to delete. देखिए इंसर्ट में भी बताया जाता है, आप एक आर्गुमेंट लेते हैं कि आपने कौन सा नंबर इंसर्ट करना है, देन यू डिसाइड कि अब इसकी प्रॉपर प्लेस क्या बनती है बाइनरी सर्च ट्री पे। इसी तरह डिलीशन के केस में भी आपको बताया जाएगा कि फलां नोड को या फलां नंबर को या फलां कैरेक्टर को डिलीट करें, ठीक है। सो on the basis of that you will decide how to delete that, where its location is in the binary search tree. So for that purpose you have several possibilities, so we will discuss those possibilities. If the node is a leaf node, it can be deleted immediately. So you know what is a leaf node? जी बताएं, what is a leaf node?
लास्ट नोड जिसके लेफ्ट सब ट्री और राइट सब ट्रीज नहीं होते हैं।
ऐसे नोड्स जिनके फर्दर लेफ्ट और राइट सब ट्रीज नहीं होते या लेफ्ट और राइट सब चाइल्ड्स नहीं होते, ऐसे नोड्स को हम लीफ नोड्स कहते हैं और ये हमेशा ट्री के लास्ट लेवल पे अवेलेबल होते हैं, ठीक है। पॉसिबिलिटी ये होती है मोस्ट पॉसिबल। सो इफ द नोड इज अ लीफ node, it can be deleted immediately because you have no complication. आपने जो उसके उन नोड्स को डिलीट करना है और उनके जो पॉइंटर्स हैं उनको नल बना देना, ठीक है। नाउ सेकंड केस क्या है? इफ द नोड हैज वन चाइल्ड. So first case is if the node is a leaf node, straight away immediately delete that and adjust the pointer. Simple, very simple. Second case, if the node has one child, the node can be deleted after its parent adjusts a pointer to bypass the node and connect to in-order successor. Like for example, you are being told that delete. Here you have a binary search tree and the elements on this binary search tree are 6, 2, 8, 1, 4, 3. So ये elements हैं और इसका left subtree भी है और right subtree भी है, ठीक है। So here you are being told that delete node 4. So if you examine node 4, it is having one child. That one child can be its left child or right child, no matter, ठीक है, doesn't matter, whatever that is. So how you will delete that node? How you will delete node 4, which is having one child, and that is its left. That is in its left subtree. So how you will do that? The mechanism is, if the node has one child, the node can be deleted after its parent adjusts a pointer to bypass the node and connect to in order successor. Now अब आप देखें 4 का पेरेंट क्या है जी बताएं 4 का पेरेंट क्या बन रहा है 6
2
4 का पेरेंट 2 है ठीक है so 4 has a parent 2 and what you will do you will bypass the pointer which is pointing towards 4 now you will point that pointer towards 3 so अब आप क्या करेंगे नेक्स्ट स्टेप में देखें अब हमने क्या किया है 2 का जो पॉइंटर कनेक्टेड था 4 के साथ देखें आपने P एंड Q दो पॉइंटर्स पढ़े थे ठीक है वही कनेक्ट करवा रहे होते हैं लेफ्ट और राइट को तो अब हमने 2 का जो पॉइंटर था जो कि 4 को पॉइंट कर रहा था उसे हमने एडजस्ट किया और 4 के चाइल्ड की तरफ पॉइंट कर दिया और वो चाइल्ड लेफ्ट भी हो सकता है राइट भी हो सकता है here in this case we have that left child that is 3 so we have connect that 3 with the parent of 4 with the parent of that node which is going to be deleted now we have isolated we have disconnected that node from its parent so what we will do we will delete now in the next step we will delete that node and the pointers will be readjusted और जो पॉइंटर अब 4 से 3 पे पॉइंट कर रहा है वो अब नल पॉइंटर हो जाएगा ठीक है now the final shape of the tree after the deletion of node 4 will be 6 2 8 1 3 ठीक है अब देखें यहां पे एक बात हुई इन ऑर्डर ट्रेवर्सल की ठीक है अब आप देखें if you take the very first diagram that is on the left side so you have these nodes and if you traverse the tree and apply the in order traversal then you will have its in order traversal as 1 2 3 4 6 and 8 so first of all you have to find the parent of that node which is going to be deleted you have to readjust the pointer and you have to readjust the pointer in such a way कि in order traversal की जो violation है वो नहीं होनी चाहिए so again if you traverse this middle diagram right in the middle of the slide so if you traverse this you will find that so you will observe that the in order traversal will still be intact that is 1 2 3 4 6 and 8 Muhammad Ibrahim 18 don't create disturbance so the in order traversal will still be intact and if we apply the in order traversal 3 4 8 deletion of node 4 and we have the final binary search tree that will be 1 2 3 6 and 8 the in order traversal
Assalamu
is still again intact so if we have a node which is going to be deleted which is going to be deleted in such a way that it has one child, then we can delete that node by adjusting its parent node pointer with the immediate in order successor, and then isolate the node and delete that node, right? So this is the case number 2, when a node which is going to be deleted having one child. So this is the statement: if the node has one child, the node can be deleted after its parent adjusts a pointer to bypass the node and connect to in order successor. So this is the example, and this is the second case. ठीक है जी? Now, what is the next case? And the next case is the most complicated case, and that is when the node to be deleted has both left and right subtrees. So this is the most complicated case, when you have to delete a node which is having both left and right subtrees, left and right subchilds. So how you will delete that? The strategy is to replace the data of this node with the smallest data of the right subtree and recursively delete that node. So what is the strategy? Replace the data of this node with the smallest data of the right subtree and recursively delete that node. Now let's see an example. ठीक है, एग्जाम्पल देखते हैं तभी हमें ये समझ आएगा. देखें यहाँ पे एक बाइनरी सर्च ट्री है और उसके नोड्स हैं 6, 2, 8, 1, 5, 3 and 4. Now we have to delete this node 2. अगर आप if you observe node 2, then you can see that node 2 is having its left subtree and its right subtree as well. So now how to delete this node? First of all, you have identified that this node has to be deleted, and now you have to find its in order successor. In order successor, देखें अगर आप in order traversing करें इस binary tree की, so what will be the in order traversing? That will be 1, 2, 3, 4, 5, 6 and 8. So 2 का in order successor क्या बन रहा है? 2 के right after क्या आ रहा है आपके पास? 3 आता है, ठीक है? So आपने क्या किया? Locate in order successor find किया. So 2 का in order successor क्या है? 3, ठीक है? So you have find out first of all in the very first step the in order successor. और in order successor कहाँ पे मौजूद है? 2 के right subtree का left most जो node है, ठीक है? वो in order successor है इसका. अब आपने ये आइडेंटिफाई किया. नेक्स्ट स्टेप में आपने क्या किया? In order successor will be the leftmost node in the right subtree of 2. The in order successor will not have a left child, because if it did, that child would be the leftmost node. So देखें left most node होता है in order successor जो होता है, ठीक है? अगर उसका further if it has its further left child, then that will be the in order successor, ठीक है? So उसका left child नहीं होगा, वो ही leftmost node होगा itself. So 3 is the leftmost node. अगर आप 4 को देखें तो वो फिर right में node जा रहा है, ठीक है? वो rightmost node है, leftmost node नहीं है. Now you will see that what we have found the in order successor of node 2, that is 3. So what we will do, copy data from in order successor. अब देखें ये नोड जो है 2 वाला, इसे हम डिलीट अगर करते हैं तो हमारे लिए काफ़ी कॉम्प्लिकेशंस बनती हैं। सो इसलिए हमें इसको इस मेथड को फॉलो करते हुए, इस एल्गो को फॉलो करते हुए डिलीट करना है, ठीक है। So what we will do, we have found in the very first step the in order successor of the node 2, and then we will copy the data of that in order successor node 3 into the node which is going to be which you have been told to be delete, ठीक है, जिसको आपने delete करना है। So 3 जो है 3 ने replace किया है 2 को, और ये जो copy है ओवरराइट हो गई है 2 की प्लेस पे, ठीक है। सो दिस इज द सेकंड स्टेप। थर्ड स्टेप क्या होगा? थर्ड स्टेप ये होगा कि अब आपने क्या करना है कि जो नोड 3 कॉपी हो चुका है 2 की प्लेस पे, उस नोड को आपने डिलीट करना है, और डिलीट करने से पहले उसके पॉइंटर्स को एडजस्ट करना है, ठीक है। So you have to delete node 3 which its value has already been copied in the proper space, in the proper place. Now you have to delete that node and you have to readjust the pointers. So how you will readjust the pointers? See this diagram. So node 3 will be deleted and you will readjust the pointer, and right after that you will get the following tree, that is 6, 3, 1, 5, 4 and 8. So if you apply the in order traversing, then it will not violate the in order traversing, it will follow the in order traversing, and the in order traversing for this will be 1, 3, 4, 5, 6 and 8. So these are the steps involved when in case 3, when you have to delete a node which is having its left subtree and right subtree as well. जी, any question?
सर वो जो आपने इन ऑर्डर सक्सेसर फाइंड किया था ना, उसकी समझ नहीं आई, और एंड पे जाके जो लास्ट वाली स्लाइड के अंदर ये जो आपने शिफ्ट किया है ना डिलीट करने से पहले, ये 2 स्टेप की समझ नहीं आई।
अच्छा जी, नाउ अब हम चलते हैं लेक्चर नंबर 9 की स्लाइड्स पे, जिसके अंदर भी ये ऑलरेडी मौजूद हैं ये केसेस, और इन केसेस को हम दोबारा से देखते हैं, ठीक है। सो पहला केस क्या था? इफ द नोड इज अ लीफ नोड इट कैन बी डिलीटेड इमीडिएटली। सेकंड केस ये था, इफ द नोड हैज वन चाइल्ड, that child can be right or left. So what you have to do, you have to find out its immediate parent and you have to adjust the pointers with its in order successor and then isolate that node and delete that node, ठीक है। ये था case 2. Now the most complicated case is case 3, when the node has when the node which is going to be deleted has both left and right subtrees. So what should be your strategy? The strategy is to replace the data of this node with the smallest data of the right subtree and recursively delete that node. Now here is the case, I am repeating it again. You have to delete node 2, ठीक है, you have to delete node 2. Now it has its left subtree and right subtree as well. Now first of all you have to locate its in order successor. The in order successor will be the leftmost node of its right subtree. 2 का right subtree क्या बन रहा है? 5, 3 and 4, यही बन रहा है ना। अब इसमें देखें लेफ्ट मोस्ट नोड कौन सा है? 2 के राइट पे है 5, 5 के लेफ्ट पे है 3 और 3 के राइट पे है 4. सो 2 का लेफ्ट मोस्ट नोड राइट सब ट्री के अंदर वो बनता है 3, ठीक है। अगर 3 का फर्दर कोई नोड होता लेफ्ट पे तो फिर हम कहते कि वो इसका इन ऑर्डर सक्सेसर है। अब यहाँ पे इस केस में 3 जो है, 3 is the in order successor. We have find out the in order successor of node 2. Clear? जी
जी सर समझ आ गया।
अच्छा, नेक्स्ट अब हम चलते हैं और इस यहाँ पे ये बताया जा रहा है कि इन ऑर्डर सक्सेसर क्या होता है और कैसे फाइंड होता है। ठीक है, राइट सब ट्री का लेफ्ट मोस्ट नोड। ठीक है, अच्छा जी, ये अब इन ऑर्डर सक्सेसर है। अब आपने क्या करना है, नाउ यू हैव टू कॉपी द डेटा, कॉपी द वैल्यू ऑफ, कॉपी करना है, कट पेस्ट, सॉरी डिलीट या कट नहीं करना। ठीक है, अब आपने वो इन ऑर्डर सक्सेसर, द इन ऑर्डर सक्सेसर विच यू हैव फाइंड आउट, you have to copy the value of that into the node which you have been told to delete. ठीक है, देखें उसकी वैल्यू ही चेंज हो गई। ठीक है, तो वो नोड समझे रिमूव हो चुका है, वो एग्जिस्ट ही नहीं कर रहा। सो 3 को आपने कॉपी किया वहां पे, ये इसका सेकेंड स्टेप हो गया। ठीक है, नाउ 3 हैज बीन कॉपीड इन दैट प्लेस which node you were asked to delete. ठीक है, नेक्स्ट स्टेप में आपने क्या करना है, अब आपने 3 को डिलीट करना है। ठीक है, जो इन ऑर्डर सक्सेसर था जिसकी वैल्यू आपने कॉपी कर दी है, अब उस नोड को आपने डिलीट करना है। ठीक है, तो उस नोड को डिलीट करने के लिए अब ये क्या क्या बन रहा है, केस जस्ट लाइक केस 2 बन चुका है। ठीक है, क्योंकि एक ऐसा नोड जिसका एक चाइल्ड है उसको आप डिलीट करने जा रहे हो, ऐसा ही है ना। देखें 3 का अब एक चाइल्ड है, 3 को आप डिलीट करने जा रहे हो, तो क्या करोगे, केस 2 को, सेम सिचुएशन ऑफ द केस 2, 3 का पेरेंट क्या है 5, 5 का आप लिंक स्टैब्लिश करेंगे 4 के साथ और 3 को आइसोलेट करके डिलीट कर देंगे, और जो आपके पास ट्री बनेगा दैट विल बी जस्ट लाइक दिस। जी क्लियर है अब?
ठीक है सर, इसका हमने वो पेरेंट नोड फाइंड करके उस जो हमने सेकंड केस किया था उसी तरह करना है इसको भी।
जी, इट इज जस्ट लाइक द सेकंड केस and it is the most complicated case, case 3, when you are deleting a node having its left subtree and right subtree. So आपने क्या करना है, उस नोड के राइट सब ट्री में जाके उसका लेफ्ट मोस्ट नोड लेना है और एंड दैट विल बिकम द इन ऑर्डर सक्सेसर। उस इन ऑर्डर सक्सेसर की वैल्यू को आपने कॉपी करवाना है। ठीक है, कॉपी करवाने के बाद आपने उस नोड को रिमूव करना है, उस इन ऑर्डर सक्सेसर वाले नोड को रिमूव करना है। हाउ टू रिमूव दैट, जस्ट लाइक केस 2। ठीक है, अब हम देखते हैं C++ कोड फॉर द डिलीट ऑपरेशन। ये तो थे 3 केसेस जो मैंने आपको थ्योरेटिकली डायग्रामेटिकली अंडरस्टैंड करवाए। अब इन्हीं का प्रोग्राम कैसे बनाना है। ठीक है, इनको C++ के अंदर कोड में कैसे इस प्रोसेस को शो करना है। ठीक है, सो डिलीट जो है, डिलीट इज C++ कीवर्ड, वी विल कॉल आवर डिलीट नोड रूटीन रिमूव। सो डिलीट को हम किसी भी क्लास नेम या फंक्शन नेम के लिए नहीं यूज करेंगे क्योंकि डिलीट एक कीवर्ड है। सो इसलिए हमें अपना फंक्शन का नेम डिफरेंट रखना पड़ेगा और हम यहाँ पे फंक्शन का नेम रख रहे हैं रिमूव। सो वी आर मेकिंग आवर फंक्शन विद द नेम ऑफ रिमूव। Here is the C++ code for remove. So see, I have called the same template class tree node factory or tree node class, and now this is working with the integer values. ठीक है, so integer type का हमारे पास tree है, remove method है, sorry, remove is the method and tree, it will work with the tree nodes of integer types, and first of all it is having a pointer variable tree and another variable that is int info. Int info is the value which is going to be deleted from the tree. ठीक है, now tree node ट्री नोड इंट टाइप के हैं और उसका हमने एक पॉइंटर, वी हैव क्रिएटेड अ पॉइंटर वेरिएबल t of that tree node class. Int cmp, int cmp, cmp stands for comparison, cmp, compare. We have taken a variable cmp and what we are assigning to it, info minus static tree arrow get info. Info is that value which is going to be deleted, minus you are performing the subtraction, tree arrow get info is the immediate value. ठीक है, info is the value which is going to be deleted, tree arrow get info is the value जहां पे आपके पॉइंटर्स मौजूद हैं. ठीक है, रेफरेंस वैल्यू. सो यू आर टेकिंग द डिफरेंस ऑफ बोथ ऑफ देम. सो इफ अगर इनका डिफरेंस, इफ कंपैरिजन लेस देन 0, it means that t equals to remove tree arrow get left. So आपने कहाँ मूव करना है? अगर वैल्यू लेस देन 0 है, सो ट्री के गेट लेफ्ट पे जाना है और वहां पे रिमूव ऑपरेशन को कॉल करवाना है और वहां पे देखना है आपने कि इन्फो वाली वैल्यू मौजूद है या नहीं. अगर वो मौजूद है तो आपने उसे रिमूव करवाना है और टी में स्टोर करवाना है. ट्री एरो सेट लेफ्ट ऑफ टी. else if cmp की वैल्यू क्या हो सकती है? ग्रेटर देन 0 हो सकती है. ठीक है, it could be greater than 0. in that case t equals to remove tree arrow get right comma info tree arrow set right of t. Now you can observe that remove is a recursive operation, क्योंकि बाइनरी ट्री जो होता है वो रिकर्सिव होता है. ठीक है, तो इसलिए रिमूव मेथड भी रिकर्सिवली कॉल किया जा रहा है. ठीक है, बार बार हम उसी रिमूव की मेथड के अंदर ही रिमूव को कॉल करवा रहे हैं और हम उसे एक कंडीशंस पे, इन कंडीशंस पे अप्लाई करते हैं. अगर डिफरेंस लेस देन 0 आता है तो गेट लेफ्ट मूव करो. ठीक है, लेफ्ट सब ट्री में जाओ. और अगर डिफरेंस जो है वो ग्रेटर देन 0 है तो आप राइट सब ट्री में टी पॉइंटर को मूव करवाते. ठीक है. अच्छा जी, नेक्स्ट क्या है? Two children replace with in order successor. Now we are discussing a case when we have to delete a node having two children or two subtrees. Else if tree arrow get left not equal to null and tree arrow get right not equal to null. ठीक है, सो आप ऐसा नोड को डिलीट करने जा रहे हैं तो आपने एक कंडीशन अप्लाई की. यू हैव अप्लाइड अ कंडीशन दैट get the left subtree, get the right subtree. If both of them are not null, then it means that it is having their two children, two subtrees. So in that case, what you will do? Tree node int static min node. You have created a min node pointer, and in that min node what you will store, min node equals to find min. Find min, you have created a method of find min and you are calling that method here. Find min tree arrow get right. So देखें क्या होता है. केस 3, द मोस्ट कॉम्प्लिकेटेड केस, उसमें जिस नोड को आपने डिलीट करना है उसके आपने लेफ्ट और राइट सब ट्री देखे, दोनों नल नहीं है, दोनों एग्जिस्ट करते हैं. इट मींस कि ये केस 3 है. अब उस केस 3 में आप क्या करते हैं कि राइट सब ट्री का लेफ्ट मोस्ट नोड उठाते हैं. ठीक है, ऐसे ही करते हैं ना, और वो मिनिमम नंबर होता है और आपने उसके लिए एक फाइंड मिन का ऑपरेशन बनाया और आपने कहा कि वो फाइंड मिन जो है वो ट्री नोड के राइट सब ट्री में जाए. ठीक है, राइट सब ट्री में ही गए थे आप लोग. ट्री एरो सेट इन्फो को मिन नोड एरो गेट इन्फो, मिन नोड की इन्फो आपने गेट करवाई. ठीक है, उसके बाद आपने उस वैल्यू को रिमूव ट्री एरो गेट राइट. static min node arrow get info, tree arrow set right of T. So remember that case 3 in which you have to delete a node by replacing the copy of its in order successor value into that node, and then you have to apply the case 2. अच्छा जी, else केस 1 भी हो सकता है आपके पास, ठीक है। केस 1 में क्या होता है, ट्री नोड int static node to delete equals to tree. If tree arrow get left equals to null, tree equals to tree arrow get right. ठीक है। केस 1 में क्या था आपके पास, will handle 0 children, जब आपके पास उसका लेफ्ट और राइट सब ट्री नल होते हैं, ठीक है, यानी लीफ नोड होता है, तो तब आपने क्या करना है, ठीक है। else if tree arrow get right equals to null, जब उसका देखें लेफ्ट भी नल है और राइट भी नल है, tree equals to tree arrow get left, else tree equals to null, delete node to delete, return tree. So आपने straight away उसके लेफ्ट और राइट सब ट्रीज को चेक किया और उसके बाद अगर वो नहीं है तो आपने नोड को डिलीट कर दिया, ठीक है। नेक्स्ट है फाइंड मिन कैसे काम कर रहा है, ठीक है। फाइंड मिन की जो रूटीन आपने कॉल करवाई थी केस 3 के लिए, वो फाइंड मिन का मेथड, दैट फाइंड मिन मेथड, हाउ इट विल वर्क, it will work with the tree node factory class and with the integer values because it's a template. Find min of tree node int static tree. So tree को आप पास करें find min के मेथड को, if tree equals to null, return null, tree null भी हो सकता है, ठीक है। if tree arrow get left equals to null, then return tree, ठीक है। return find min tree arrow get left, so आप राइट सब ट्री में जाते हैं और उसका लेफ्ट मोस्ट नोड जो होता है, लेफ्ट नोड जो होता है उसको फाइंड मिन के अंदर प्लेस करते हैं और उसे रिटर्न करवाते हैं, ठीक है। Now that was the code for the 3 cases of the deletion cases in binary search tree. Now let's design the binary search tree class, that is binary search tree class factory, ठीक है। उसका कोड देखते हैं जिसको हम बार बार यूज कर रहे हैं, ठीक है। So if and def binary underscore search tree underscore h hash define binary search tree hash include iostream binary node and forward declaration, ठीक है। forward declaration template class e type, e is the type parameter and we are creating a binary search tree class binary search tree, and this is forward declaration. Forward declaration means without the body you have just defined its class, ठीक है। Then you have template class e type, e is the type parameter, class binary node. Why we are making it template class, because we want to handle different data types with the same class. So class binary node e type element binary node static left binary node static right। देखें आपने p एंड q 2 पॉइंटर्स पढ़े थे, तो अब जब बाइनरी सर्च ट्री आप बनाने जा रहे हैं, एक ऐसी क्लास बनाने जा रहे हैं जो कि बाइनरी सर्च ट्री की फैक्ट्री है या बाइनरी सर्च ट्री बनाती है, तो बाइनरी सर्च ट्री में लेफ्ट और राइट आपको 2 पॉइंटर्स चाहिए। सो यू हैव क्रिएटेड the 2 pointer variables left and right with the binary node class. Now binary node const e type ampersand the element comma binary node static lt for left comma binary node static rt for right, ठीक है, ये फॉर्मल पैरामीटर्स हैं। कॉलन एलिमेंट, द एलिमेंट कॉमा लेफ्ट फॉर LT फॉर लेफ्ट, RT for right. Friend class, binary search tree, E-type. Now this class, binary node, is the friend class of binary search tree, BST, which is the major class. So why you are making it a friend class? Because you want to share all the methods and all the member variables of this binary node class with the binary search tree class. So that's why you are using the friend class concept, and you have already studied this friend class concept in your C++ programming fundamental subject. Then you have template class E-type class binary search tree. In the public binary search tree, const E-type ampersand not found. Binary search tree const binary search tree ampersand RHS, right hand side. These are the two, ये दो क्या हैं, कंस्ट्रक्टर्स हैं, ठीक है, जो कि बाइनरी सर्च ट्री को इनिशियलाइज करवाएंगे, ठीक है. देन यू हैव द डिस्ट्रक्टर बाइनरी सर्च ट्री, const E type ampersand find min, const E type and ampersand find max. So ये आपने जो बेसिक ऑपरेशंस हैं वो बाइनरी सर्च ट्री के अंदर पुट की हैं. फाइंड मिन का चाहिए आपको ऑपरेशन, फाइंड मैक्स का चाहिए हो सकता है. const E type ampersand find const E type ampersand x, const bool is empty मेथड भी आपको चाहिए क्योंकि आपका बाइनरी ट्री जो है इनिशियली एम्प्टी हो सकता है, ठीक है. Then you have void print in order const. So you need in order traversing technique as well for the binary search tree. So you have put all those basic methods in the binary search tree class, in the binary search tree factory class, which is a template class as well, and you have made them public. Then you need the two routines, void insert const E type ampersand x. E type is the type parameter. Void remove const E type ampersand x. देखें, आपको बाइनरी सर्च ट्री जब जेनेरिक एक क्लास बनानी है तो उसमें देखें आपको ये मेथड्स चाहिए. आपने बाइनरी सर्च ट्री अगर डेवलप करना है तो आपको नए नोड उसमें इंसर्ट करने पड़ते हैं, तो आपको इंसर्ट रूटीन चाहिए. और अगर आपने बाइनरी सर्च ट्री में से किसी नोड को डिलीट करना है तो आपको रिमूव मेथड चाहिए, और ये रिमूव मेथड वही है जिसको अभी हमने डिस्कस किया है. और ये रिमूव मेथड उन तीन केसेस की बेस पे वर्क करता है, ठीक है. यानी लीफ नोड है तो डिलीट करो स्ट्रेट अवे, और अगर ऐसा नोड है जिसका वन चाइल्ड है तो उसको कैसे डिलीट करना है, और अगर ऐसा नोड है जिसका लेफ्ट और राइट सब ट्री है तो उसको कैसे डिलीट करना है. यहाँ पे जस्ट वो रिमूव मेथड कॉल हो रहा है, ठीक है, और अलग से मैं उसको आपको समझा चुका हूँ. const binary search tree ampersand operator equals to const binary search tree ampersand RHS. Now that was the public part of the binary search tree template class. Now what is the private? In the private we have defined some member variables. Binary node E type static root. So आपको एक root pointer variable चाहिए जो कि जो पहला node होगा binary search tree का या binary node class का, that will become the root node. const E type item not found. देखें, आपको बाइनरी ट्री के अंदर कोई एलिमेंट सर्च करने के लिए कहा जा सकता है, ठीक है. आपने एक वेरिएबल लिया आइटम नॉट फाउंड का, ठीक है. दैट विल बी रिस्पॉन्सिबल फॉर स्टोरिंग द इंफॉर्मेशन इफ इट इज failed to detect any number on an existing binary tree. Const E type ampersand element at binary node E type static T, void insert const E type ampersand x बाइनरी नोड ई टाइप स्टैरिक एम्परसेंड टी, वॉइड रिमूव, ठीक है। ये अब वो मेथड्स जो हैं यहाँ पे कॉल हो रहे हैं, ठीक है, उनकी प्रोटोटाइप डिक्लेयर हो रही है, ठीक है। वॉइड इंसर्ट, वॉइड रिमूव और उसके जो भी नंबर ऑफ पैरामीटर्स होंगे। बाइनरी नोड ई टाइप फाइंड मिन, बाइनरी नोड ई टाइप फाइंड मैक्स, ठीक है। ये उनकी प्रोटोटाइप यहाँ पे डिक्लेयर हुई है, और इससे पहले जो थे वो यहाँ पे कॉल हो रहे थे, ठीक है। अच्छा जी, अच्छा जी, बाइनरी नोड फाइंड मिन, find max, and then simply the find operation, any number which you have to find on a binary tree. Void make empty, अब कोई भी बाइनरी ट्री हो सकता है जिसपे आपके पास ऑलरेडी नंबर्स मौजूद हैं। सो इफ यू वांट टू मेक इट एम्प्टी, then you can remove all the binary nodes from that binary search tree and your tree will become empty. Null, void print in order, and you have another method, and it is taking the following arguments: binary node e type static t. So this is the section or the of the binary search tree class, or the binary search tree factory class, having the following private members. The symbol ampersand has a few different purposes depending on where it occurs in code. Now, अगर आप इस example को देखें, ये जो binary search tree की आपने class देखी है, it is quite complicated for you, I know that. So you can study this class as well as you can study other solutions available in your book for the binary search tree. वो codes भी आपने देखने हैं, और उसके अलावा भी जो method आप देखना चाहें और जो आपको easy लगे उसे आप देख सकते हैं, ठीक है। अब देखें यहाँ पे एम्परसेंड बार बार यूज हो रहा है, ठीक है। एम्परसेंड कभी वेरिएबल से पहले आ रहा है, कभी वेरिएबल के बाद आ रहा है, ठीक है। सो ये हैं एम्परसेंड के डिफरेंट यूजेस, जो कि हम नेक्स्ट लेक्चर में होपफुली कवर करेंगे। अगर अब तक आपका इस लेक्चर में से कोई क्वेश्चन है तो आप पूछ सकते हैं। सो हमने नेक्स्ट जो लेक्चर होगा स्लाइड नंबर 38 से शुरू करना होगा, और जिसमें हम पढ़ेंगे रेफरेंस वेरिएबल्स के मुतालिक, और रेफरेंस वेरिएबल्स में हम एम्परसेंड का यूज देखेंगे कि एम्परसेंड को हम कैसे डिफरेंट पर्पसेस के लिए प्रोग्रामिंग के अंदर यूज करते हैं, ठीक है। कहाँ पे ये एड्रेस ऑफ ऑपरेटर के तौर पे काम करता है, कहाँ पे ये रेफरेंस पास करता है, ठीक है, एज अ रेफरेंस पैरामीटर काम करता है, कहाँ पे ये किस वे में बिहेव करता है, ठीक है जी। सो इफ यू हैव questions related to today's lecture you can ask. जी
नो सर।
ठीक है जी, that's all for today, and I will upload the lecture slides. कुछ तो लेक्चर 8 की हैं और कुछ 38 स्लाइड्स जो हैं वो लेक्चर नंबर 9 से, ठीक है। सो आपने इनको अपनी बुक में से भी और लेक्चर स्लाइड्स में से भी इनको टाइमली प्रिपेयर करना है साथ साथ, ठीक है, क्योंकि जैसे जैसे हम प्रोसीड वी आर मूविंग फॉरवर्ड, थिंग्स आर बीइंग कॉम्प्लिकेटेड, ठीक है। और अगर आपको प्रीवियस कॉन्सेप्ट्स नहीं है तो आपके लिए प्रॉब्लमैटिक होगा। ओके जी, दैट्स ऑल फॉर टुडे। अल्लाह हाफिज।
सर